This is the series circuit. In the series circuit, we connect the batteries, we connect the bulbs in this manner. Terminal 1, this is terminal 1 of bulb 1, terminal 2 of bulb 1, and this is terminal 1 of bulb 2. So we connect them in this form. So this is how you connect the bulbs in series. So from the battery positive terminal, we go to the fuse, 5 ampere fuse, we come to the switch. Now this is how we connect the bulbs here. That is bulb 1, bulb 2, bulb 3 and 4. Bulb 1, so you have bulb 1, 2, 3, then we go back to the negative battery terminal. So that is the connection, and that's how the whole circuit looks like. That's how the whole circuit looks like. Now let's take the voltage measurement so that we see how this voltage is going to behave. But note that the bulbs are dim, so they are not lighting that much. So for this case, now we are going to measure the voltage across each bulb and also the current taken by the 3 bulbs. Let's do it. Now we take the voltage measurements across the bulb. Across the first bulb, the voltage is 4.03 volts. Across the second bulb, the voltage is 3.73 volts. Across the other bulb, the voltage reading is 3.98 volts. We now determine the current taken by the 3 bulbs. So for current, we take this one here. Okay, remember that we set this one to measure the 20 amperes, and we take this one here, just disconnect, can put the switch off in that case. Just the way we did in the first one. Now we put the switch on. So now note the current. The current is 1 amperes. So the current taken is from here, it's coming to 0.99, so you record that as 1 ampere. So that's what we've got. If you add this 4.3, 3.7 plus 3.9, this should be approximately equal to 12 volts because our battery is a 12 volts battery. Now we connect a circuit in parallel. This is a parallel circuit. Note how the bulbs have been connected. Now in this one, we are going to determine the current across bulb 1, current across bulb 2, current across bulb 3, and we are going to determine the total current in the circuit. From there, we are also going to find VB1, voltage across bulb 1, VB2, and VB3. All that we are going to use a switch to activate the circuit, and we are going to use the 10 ampere fuse, which is going to protect our circuits. So for us to connect the bulbs in parallel, these bulbs need to share common leads. So those ones there and this one here. So I combine all of these together. After combining them together, I give them the positive voltage. Give them the positive voltage. The positive side of the wire, it's this wire here. Do like that. Then I connect them. The other 3 leads, they come together. Connect them together. You can also do it through a wire, but I find this one being easier. So when I pair them together like that, then I take this wire from the negative side and I apply it to the here, the wire from the battery connected here. So now let's see what we are going to have in this circuit. In terms of the brightness, first we compare this circuit with the bulbs connected in series. So as you can see, the bulbs appear brighter. So series connection, the bulbs were dim, but in parallel connection the bulbs were brighter. Now I want us to take the voltage measurements. See the voltage. Remember that they have all been connected across this lead and this lead. So now let's get the voltage measurements here. So this is the negative, it goes there. To change the multimeter, 20. So that is 11.14. So with these measurements we can see that the voltage drop across each bulb is 11.14, and that's why the bulbs are appearing brighter than when we compare them by the time they were in the series connection. So that's why we connect the automatic load. So that's why we connect the automotive loads in series, in parallel, including the bulbs. The only thing that we can connect in series is the switches. Now let's take the voltage, now let's take the current measurements, and to do that just need to disconnect one lead here. I need to change the multimeter settings. So I get this wire from, put it here, enable the multimeter so that now it records the current. Now let's see the current consumed by the whole of this circuit. Now note that now the current is 5 amperes. So bulbs in series, they were consuming very less current. That was around 1 ampere. Now they were dull, and the voltage across each bulb was 4 volts, approximately 4 volts. But now for this case, the voltage across each bulb is 12 volts and the current is 5 amperes. So these bulbs are seeing more current, more voltage, translating to more power, therefore being brighter. So this is the reason why all electrical loads must be connected in parallel, including the bulbs, motors, and everything else. Now in our next video we are going to be looking at how we can use a multimeter to know if the the fuse has blown off or if the fuse is still okay. So we meet in the vehicle next time. We take the measurements across the fuses using a multimeter and using a test line. See you in the next one. Remember to subscribe. I am your trainer, Mr. Paul. Thank you.